Hi, I'm Dave Nobles, and this is the amazing story of how APL captured the first images of the Earth from space.
3, 2, 1, 0. Rocket away.
Our story starts just after World War II. One of the several benefits of defeating the Nazis was the capture of 130 V-2 rockets, along with construction plans and thousands of spare parts. APL's first director, Merle Tuve, a very savvy fellow, convinced the Navy to give APL one of the V-2 rockets, complete with a warhead and other components for research. Enter our main character, APL's very own Clyde T. Holliday. Clyde was a photographic specialist who helped create photo tracking techniques on both APL's proximity fuse and Bumblebee programs. Clyde joined forces with the now famous APL physicist James Van Allen in the High Altitude Research Group. Oh, by the way, Van Allen discovered the Van Allen radiation belts. Those are the two donut-shaped regions surrounding Earth that trap some of the high-energy particles emitted by solar activity that protect our atmosphere from destruction, but I digress. So Clyde set to work, devising a camera system that had to be robust enough to handle the shake, rattle, and roll of takeoff, and then survive literally being smashed to Earth upon its return. They tried using large parachutes for recovery, but the parachutes couldn't handle those hypersonic speeds. It was a critical challenge. So what did they do? What APL does. They found a solution. To protect the film, APL designed a hardened steel cassette that could hold a 100-foot reel of film that would last 300 seconds. They also painted the cameras bright red to make them easy to spot after crash landing in the desert. On October 24, 1946, at the White Sands Missile Range, Clyde installed a modified 35mm combat newsreel camera into a V-2 rocket. So how'd it go? In Clyde Holliday's own written words, the test was completely successful. However, it is realized that its success was mostly blind luck. The camera was placed in actual contact with the liquid oxygen tank without any form of insulation, and the rocket stayed on the ground with the fuel tanks filled for several hours before firing, giving sufficient time for the entire camera to become so cold as to make operation almost impossible. It came very close to not working. But it did work, Clyde. As a result, APL presented the world with the first images of the planet from space, 65 miles up. The view of the curvature of the Earth was unlike anything anyone had ever seen before. It was beautiful. History was made that day, all thanks to a lot of luck, and of course APL engineering. And that, my friends, is the story behind the science.